Okay, so in section 1 and section 2 of chapter 6, we talked a lot about rational exponents and fractional exponents and how those change to cube roots, fourth roots, fifth roots, and all that stuff. Today we're going to talk about functions and function operations. So, like I said, your exponent rules might come into play in some of these problems, but it's not going to be a major focus. The major focus is on functions. So let's just talk about function operations. Now, operations are mainly adding, subtracting, multiplying, and dividing. Okay? So if you hear about anything about perform so-and-so operations, operations are just adding, subtracting, multiplying, dividing for the most part. There's other operations, but those are the main ones. So we're going to start with having two different functions, and they have different names. This one's called f of x, and this one's called g of x. And these are both linear functions because they don't have a square or any exponents on their variables. So these would be graphs of straight lines. Remember, in a function, x's never repeat. They pass a vertical line test. Those are all some traits of functions. But we want to do some operations on them. So we're going to take these same two functions, f and g, and we're going to make a new function out of them called h. Okay? And the x in the parentheses just means this is a function of x's. Okay? So we're going to put them together and make a function called h. And the first way we're going to do it, it says h of x equals f of x plus g of x. So first they want us to find f of x plus g of x. So the way we find f of x plus g of x, we call it h of x. That's what its name is going to be. We're going to take f of x and we're going to write it down. F of x equals 5x. Okay? And then I'm going to add it to g of x. So I'm going to say 5x plus x plus 2. Here's my f of x. Here's my g of x. Just add them together. So you just combine like terms. What's 5x plus x? So h of x is going to be 6x plus 2. There it is. That's all you do. Take the two functions and add them together. Yeah. So let's do, this time it tells me h of x equals f of x minus g of x. Now, g of x has more than one term in it, doesn't it? So when I do my minus sign, I need to use parentheses. So I'm going to have 5x minus parentheses x plus 2. If you have more than one term for your function, you need to use parentheses. And that means we distribute a -1, which means we will change all the signs for g of x. So that means h of x will equal 5x. -1x, well, -1 times x is -1x. -1 times 2 is -2. And what's the last thing I do? Combine or like terms. 5x minus 1x is 4x. So this one is h of x will equal 4x minus 2. And there's that answer. Questions so far? All right, now let's multiply. So the next one will tell me h of x will come from f of x times g of x. So what do you think I do to find h of x? How do you think I do f of x times g of x? Yeah, 5x times. Yeah, and I'm going to use parentheses. So h of x equals 5x times x plus 2. And I just distribute, don't I? Yeah. So h of x will equal, what's 5x times x? 5x squared. What's 5x times 2? 10x. And there's my answer. Because they're not like terms. And the last one of these I'm going to do is I'm taking the same functions and I'm doing these different operations to them, basically. I have them listed as separate examples, but they're coming from the same functions. F of x divided by g of x. So you just take f of x and put it on top of g of x. That's all you do. So this one is h of x equals 5x over x plus 2. Now, y'all, the thing that people get confused about for functions and function composition and function operations is the notation of it, right? Like if you just get consumed with the symbols, it might drive you a little crazy. Does that make sense? Like if you just look at this, you're probably like, what in the heck is going on? Right? But just know this means this function. F of x is just the name of a function and g of x is just the name of a function. You could call them Sam and Bill if you want to. I mean, you know what I mean? Like it's nothing except for you're just going to take this function of f and this function of g and apply them together, and I'm going to trip over my hair. Okay? So don't get too confused with the notation of it, the symbols and stuff. See, this will not simplify, so you leave it like this. There's your answer. All right, they're going to give us another set of functions now. This time, all right, they're going to do a little bit of our exponent stuff here. They're going to say f of x is 4x to the 1/2 power, and g of x is negative 9 to the 1/2. Negative 9x, my bad, to the 1/2 power. So they want us to find two things. First, they want me to do f of x plus g of x. And then they want me to find f of x minus g of x. That's the two things we're going to find for these two. So, f of x plus g of x, I just write down f of x, which is 4x to the 1/2, plus g of x is negative 9 x to the 1/2. And I use parentheses, so I'm saying plus a negative there. Do y'all see that those x's both have the same exponent? So what I would do is I would kind of put the whole numbers together. So 4 plus negative 9 isn't the same thing as 4 minus 9. Does that make sense? So just take the coefficients and put them together. And since the x's are the same, it's kind of like reverse. I'm factoring the x to the 1/2 out. Does that make sense? Kind of what I'm doing is factoring. And then I'm going to combine the 4 and the 9. So what is 4 minus 9? Negative 5. So the answer is negative 5x to the 1/2 power. So I'm going to do the next thing up, same thing over here, except I'm subtracting f minus g. So I'm going to say 4x to the 1/2 power minus 9x, minus negative 9x, sorry, minus negative 9x to the 1/2 power. And minus a negative is the same thing as what? Adding, right? So I'm going to do the same thing. I'm going to put my 4 and my 9 together because they have the same exponent. And what is 4 plus 9? 13. So So it's 13x to the 1/2. So any questions on those? All right, let's get some more functions. Sorry, I'm not trying to rush ahead of y'all. That's just where I was on the page. Two more functions. This one is f of x equals 6x. Next one is x equals x to the 3/4. So there's some more of those rational exponents. So, example G, we're going to do f of x times g of x. And for example H, they want us to do f of x divided by g of x. So for f of x times g of x, I'm multiplying. So I'm going to multiply 6x times x to the 3/4. Now, aren't those x's like bases? So what do I do if I'm multiplying two things with the same base? Add the exponents, right? So I'm going to be adding 1 plus 3/4. What's 1 plus 3/4? Yes, it's 1 3/4. 1 3/4. We make it improper. 1 times 4 is 4 plus 3 is 7. 7/4. So the answer is 6x to the 7/4. Do y'all see what I did? I kind of skipped a step. But these are multiplied, so I add it. 1 plus 3/4 is 1 3/4. I made it improper. And that goes on your x. Does that make sense to everybody? Questions? All right, so now let's divide them for problem 8. F of x divided by g of x. So I take f of x, put it over g of x. Now, what do I do if I divide two things with the same base? Subtract their exponents, right? So that's a 1 on top. So what is 1 minus 3/4? Well, 1 is 4/4, right? 4/4 minus 3/4 equals 1/4. So this is 6x to the 1/4. So it's really not so bad. I think I do want you to try a few of these real quick. And they're in the book, so you'll need to open your book. Page 429. I want you to do 1 and 2 and 4 and 5. Do 1 and 2 and then 4 and 5. You won't be able to do it if you don't try. Practice makes perfect. It is because you've seen a lot of it in Algebra 2. So it's not easier. It's just the same thing repeated for a lot of things. They go into more depth in a lot of them than we have time to do. But since you see Algebra 2, you're seeing a lot of it brand new, never seen before. And a lot of it's repeated because it's college algebra, so it repeats a lot of Algebra 2. It's easier. This branch math is sending that. It's supposed to help you do it better on your ACT. Okay. How do I set up number 1? What do I write? Seven x to the 2/3. So how can I do this? The -2 and the 7 together? Nope. Plus 7. Because I have the same exponent. I didn't give myself enough room. Let me move that down. Okay. So you just combine your numbers in front. What's -2 plus 7? So that's 5x to the 2/3. Raise your hand if you got 5x to the 2/3. Are there any questions about that one? Okay. So I'm subtracting on number 2. So what do I write down? What's f of x? To the 2/3 minus 7x to the 2/3. And then I combine my front terms. -2 minus 7x to the 2/3. And what's -2 minus 7? So -9x to the 2/3. Raise your hand if you got -9x to the 2/3 for that one. Okay, good job. The next time they gave us a new f and a new g. So number 4, they want you to multiply. So I would say 3x parentheses or times, however you want to do your times, x to the 1/5. How do I add multiply my x's? I add, right? What do I add? What's 1 plus 1/5? Yeah, 1 plus 1/5 is 1 1/5, which is 6/5. So 3x to the 6 over 5. Raise your hand if you got that. Any questions about that? Fraction arithmetic is important. That's why you've done it since 4th grade. How do you divide these functions? What goes on top? 3x for f of x. And what goes on bottom? And when you divide two things that have the same base, what do you do with them? Subtract exponents. So what is 1 minus 1/5? 4/5. So the answer is 3x to the 4/5. Anybody get that right? Okay, good job. All right, so next thing we're going to talk about is function composition. Composition of functions. So what you have when you're doing a function composition is you're taking one function and composing another function along with it. Okay, so we're going to start out really easy. They're going to give us two functions like they've been. This is example I, by the way. They're going to give us, you can't see my I. It's an I. No, we did H was the second part of, was the division part of the last one we did. F of x equals 2x minus 7. And g of x is going to equal x squared. And they want us to find g of f of 3. Now, y'all don't let the notation completely throw you off. When you have function composition, you're gonna work from the inside out. Okay? So we want to find f of 3. and then put that into the function g. Okay? So whatever's in parentheses is what I want to put inside my x's. Okay? Whatever's in parentheses is what I'm putting in for my x's. So I'm going to ignore g for a second. I'm going to work on f of 3. So I'm going to come over here where f is, and I'm going to find f of 3. So that means where they have an x, I'm going to put a 3 in. So I'm going to say 2 times 3 minus 7. And what is 2 times 3? 6. And what is 6 minus 7? So f of 3 equals negative 1. So again, I'm taking what they told me to find, and I'm working from the inside out. So I found f of 3. So this function, f, when x is 3, is negative 1. It's basically the y value of that function, okay, if I was talking about lines. Okay? So then I'm going to take that solution, and I'm going to put it in to g of x. So here's what it says. Find f of 3. So find g of f of 3. So I found f of 3, then I plug it into g. Start on the inside, work your way up. Okay? So then I'm going to plug that answer into g. I'm going to say g at negative 1 equals every x turns into a negative 1 now. Negative 1 squared plus 4. What is negative 1 squared? What is 1 plus 4? So my answer for f g of f of 3 equals 5. So start on the inside, work your way out. So another one. These are some of the easiest ones today, I think. I'm listening. Okay. Been there. This is backwards. They want us to find f of g of negative 3. So I told you to work from the inside out. So what are we going to do first, do you think? Right, so I'm going to use function g, which is this function, and I'm going to plug in negative 3 for all my x's. Okay? So g of I'm going to use red. G of negative 3. So that would be negative 3 squared minus 1. Negative 3 squared. Positive 9 minus 1 is what? Oh, sorry. So there's my inside is 8. So my g of negative 3 was 8. So now I'm going to find f of that. So every time I see an x in the f function, I'm plugging in an 8. So 3 times 8 is, and 24 minus 4 equals what? 20. Y'all understand working from the inside out? Okay, so you start with the inside function. If you have a number in parentheses, you plug that into the inside function, and you plug that answer into the outside function. But they're not always going to give you a number right here, unfortunately, because those are easy. We can just do arithmetic, right? So they're not always going to give you a number right there, and you have to do function composition another way. So here's our example K. So this setup is a little different. They tell me f of x equals 4x to the negative 1 power. G of x equals 5x minus 2. And it says find the following. And it's going to give us three things they want us to find. First thing it wants us to find is f of g of x. Then it wants us to find g of f of x. And then it wants us to find f of x. That's hard to say. F of x. Lots of f's in there. Makes you sound like you're stuttering. F of x. Okay. We don't know what x is. So we're not going to get a nice, pretty little number for our answer like we just did. Okay? But what we are going to do is we're going to get another function. So you're starting with two functions and you're getting another function. Okay? So what you're going to do is you're going to take the inside function and put it into the outside function. Okay? So let's think about it. G of x equals this, right? So I'm going to take this and insert it in for the x right here. Okay? So I'm going to take this and put it in here. That's what f of g of x is. I take g of x and I put it into f, in for the x. Okay? So what that's going to look like is I'm going to copy the 4. And where they have an x here in f, I'm going to use parentheses. And I'm going to insert my g of x. And that's to the negative 1 power. So I'm going to put my negative 1 power. So where there was an x for f, I'm plugging in all of g of x. Does that make sense? So where I have parentheses is where there originally was an x. So I'm taking g, putting it inside of f. Okay? Now I'm going to simplify it. Well, it says this whole binomial right here is to the negative 1 power. What do we do with negative exponents? Other side of the fraction. So the 4 does not have that negative 1 exponent, though, does it? So it's going to stay in the numerator. And we'll pull that to a denominator. And it's going to be 4 over 5x minus 2. All I can do to it. Uh-oh. I tried to erase it. I was trying to highlight it. Yeah. There we go. That's my answer. Okay? Now, I'm not going to get the same thing when I do g of f of x. So that was f of g of x. Now I'm going to do g of f of x. So that means I'm going to take f of x and insert it in for the x of g of x. So let me re-highlight here. I'm going to take all of f of x and put it in for the x of g of x. Go with me? Inside goes to the outside. Inside goes to the outside. So 4x minus 1 is going to go into the x for 5x minus 2. So here's what that's going to look like. We'll have 5 parentheses. I'm going to insert the 4x to the negative 1 power. And then write minus 2. Y'all see that? We are going to multiply times 5. Do y'all see that? Inside goes to outside. So f of x goes into g of x for the x. Does that make sense? Inside goes to outside. All right. So multiply here. 5 times 4x to the negative 1. Isn't that 20x to the negative 1? And then minus 2. And negative exponents go to a denominator. 20 does not have a negative exponent, just the x does. So the answer is 20 over x minus 2. That's your final answer. Does that make sense? 20 over x minus 2. You could technically, no, you can't put that. You can't put that on the numerator. You cannot. All right, so the last one they want us to do is f of x. So that means I take all of f of x and put it into the x of f of x. So that means I'm going to say, I'm going to take 4x to the negative 1 and put it into x for 4x to the negative 1. Which means, yeah, I'm going to take the whole thing that's yellow and substitute into the green. So I'm going to say 4 parentheses 4x to the negative 1 raised to the negative 1. Does that make sense? I took f of x, which is this part, and I put it into the x for f of x. Does that make sense? Kind of ish. All right, so first thing I need to do is fix my parentheses. They all have a negative 1 power, so they all get the negative 1 power. Keep the 4 on the outside. What's 4 to the negative 1? 4 to the negative 1, right? And what's negative 1 times negative 1? 1. So that means this one has to go to a denominator, correct? So that is 4 over, or you could add them, couldn't you? That might be simpler. These are just like bases, aren't they? And that'd be 0, and anything to the 0 power is what's anything to the 0 power equal? What's calculator say? 4 root top 0. One. Anything 0 power equals 1, so the answer is 1 times x, which is x. If you want to do it exponent rules way, if you want to do it, move it to the bottom, you still get the same answer, because that's going to be 4 divided by 4x, and 4 divided by 4 is 1. So there you go. Either way, you just get x. How are we going to get good? Practice. That was example K. Let's do L. We get another set of functions now. F of x equals 6x to the negative 2. And g of x equals 4x plus 5. We want to find three things again. We want to find f of g of x. We want to find g of f of x. And this time we want to find g of x. I know. Okay, so what does that mean, f of g of x? What does that mean? What do we do? That's right. I take all of g of x and put it into the x of f of x. Okay, so you start with the inside, you go to the outside. So you take the inside, put it into the x of the outside. So I'm going to write 6 parentheses 4x plus 5 to the negative 2 power. Now what do I do with negative exponents? Other side of the fraction. So it's just going to be 6 over 4x plus 5 all squared, and you can leave it like that. Oh, this is really not so bad. It's confusing. I ain't gonna lie. It's confusing. but the math is not super difficult. All right, now we're going to do g of f of x. So that means we start at the inside, work outside. So we're going to take all of f of x, put it into the x of g of x. So I'm going to start writing g of x, and when I come to the x, I'm going to use parentheses and put in my 6x to the negative 2, and then finish writing g of x. So I took all of f of x and put it into the x of g of x. Everybody understand my setup there? All right, then we multiply. 4 times 6x to the negative 2 is 24x to the negative 2, right? And then plus 5. And what do I have to do with that negative exponent? Yep, so that's going to be 24 over x squared and then plus 5. And that's all we can do to that one. And the last one is g of x. How do you think you do g of x? Yeah, you take all of g of x and then put it into its own x. Does that make sense? So I'm going to start writing g, which is 4 times x plus 5. And where I need the x, I'm going to put in there 4x plus 5. Does that make sense? So where I have parentheses is where the x was originally, and I just put all of g into that x. So that's g of x. What do I have to do with that 4? It's just distributing, right? So 4 times 4x is 16x. 4 times 5 is 20. And then I have plus 5. So those are like terms. My answer is 16x plus 25. That's it. I ain't gonna lie, it can be confusing. I've got one more example, and it's actually a problem out of the book. For the homework part, we're obviously not going to do it since we're doing it in our notes, but I thought it was pretty good. It's number 31 in the book. It's a multiple choice question on the homework. But it says, what is g of f of x when f of x equals 7x squared and g of x equals 3 to the x minus 2, or 3x to the negative 2 power. I said that wrong. 3x to the negative 2 power. Question mark. So we're finding g of f of x. How do we do that? Yeah, that's right. So I'm going to take all of f of x and substitute it into the x of g of x. Remember, you start on the inside and work out. So we take f of x and insert it into g of x for the x. So that's going to be 3 parentheses 7x squared parentheses negative 2 power. So what do you think is the first thing we got to do? You could. Or you could just give everything in parentheses the negative 2 power, right? Yeah, let's do that. That's what I would do first, just fix my parentheses. So I have 3 times, it's not parentheses, 7 to the negative 2 times x to the negative 4, right? Multiplied my exponents. Everything on the inside. Does everybody get that? And now I'm going to move my negative exponents. So first I had to give everything a negative 2 before I can move them. Does that make sense? So that's going to, huh? Power of a power, though, would multiply them. Yeah. So that's going to be 3 over 7 squared x to the 4th. And what is 7 squared? So it's 3 over 49 x to the 4th. Is that final answer? All right, we're going to call that the end of section 6.3. Have a good day.